Okay, welcome back. This is Mr. Hassan's Maths channel. I'm now going to answer question number 4 from the 9709 Cambridge International A-Level Pure Mathematics paper 3. This question here is about parametric equations, and here we're told that the parametric equation of a curve, or the parametric equations of a curve, are x equals e to the power of 2t minus 3 and y equals 4 ln t, where t is greater than 0. And it tells us that when t equals a, the gradient of the curve is 2. Show that a satisfies the equation a equals a half times 3 minus the ln of a. So here we have what are called parametric equations. Now, a parametric equation is an equation which is expressed in a form where you have 3 kind of parameters, you could say, right? So you have x, y, and in this case you have t as well. A Cartesian equation is where you have something expressed in terms of just y and x. All right. Sometimes you can quite easily convert something from parametric form into Cartesian form. Okay. Now in this case here, we have x equals 2t minus 3 and y equals 4 ln t. So, I mean, how do parametric equations work? I mean, I'm kind of diverging, or from the actual topic here, from the actual question here, just to give you a bit more understanding about parametric equations. As I said, these videos are not just for me to answer these particular questions, they are also, I use them to give a better understanding of the main topic as well. So I'm going to just go into a bit more detail about, for example, if you were to plot this. Supposing you wanted to plot this graph, although we're never asked to do this, but it gives us an understanding of how they work. So you would have a table of values which include 3 parts. Okay, you have your t values, and you have your x values, and you have your y values. Right? So in this case, it says t is greater than 0. So let's say you start from 1, 2, 3, 4, and so on. So you'll have the x value and the y value when t equals 1. So when t equals 1, x is going to be e to the power of minus 1. Okay, because you're going to have 1 in here, that'll be 2 minus 3 minus 1. And when t equals 1, you'll have 4 times ln 1, which is 0. 4 times ln of 1 is 0. When t equals 2, you have e to the power of 4 minus 3, which is e to the power of 1. And you have 4 times ln 2. You can leave it as 4 ln 2, no problem. You can call that ln 16 if you want, using the power law. And when t equals 3, you're going to have 6 minus 3, which is 3. So have e to the power of 3. And that will be 4 ln 3, and so on. It will continue. This will be e to the power of 5. And that will be 4 ln 5, and so on. Okay, so you have now these values that you could plot. You could plot e to the power of minus 1 against 0. You can plot e to the power of, e to the power of minus 1 against 0, e to the power of 1 against 4 ln 2, and so on. So you get pairs of values which you can then plot. So that's how you would plot a parametric curve. So just give you like some kind of reasoning behind it. And we could also convert this in Cartesian form, by making t the subject of one of them and substituting to the other. But in this case, we don't need to do this at all, right? In fact, we need to have the gradient. We need the gradient of the curve in terms of t, because we want to find we're told that the gradient of the curve is 2 when t equals a. So we have to have t in our in our formula to make it possible. So how do I find the gradient of the curve? Now we know that the gradient of a curve, if we have your x and y axis, is basically the change in y over the change in x. Okay, we know the gradient is a change in y over the change in x. All right, if there's a curve, okay, we find it's like the gradient at a particular point by differentiating. dy dx is the gradient function. This is called the gradient function. So what we have to do here is we have to find what dy dx is, but in terms of t. So how do you find dy dx in terms of t? Well, we're going to use the chain rule. So when you have a parametric equation, when you have x in terms of t and y in terms of t, you use a chain rule. You say, okay, let's find dy dt, which you can find, and multiply that by dt dx. We can find dx dt, and write its reciprocal, that will be dt dx. When you multiply them together, that will give us dy dx in terms of t. So we take the y value, which is 4 ln t, and we find what dy dx is. Now dy dx, if you have 4 ln t, it's going to be 4 over t. We know when you differentiate ln t, you get 1 over t. That's 4 times 1 over t, which is 4 over t. And we know that x equals e to the power of 2t minus 3. So dx dt, let's find dx dt first. Now, when you differentiate something, e to the power of something, it stays exactly as it is. It doesn't change. So it's e to the power of 2t minus 3. However, you have to also multiply by the differential of what's inside the function. This is, the chain rule. So in this case, if you look what's inside the function and you differentiate that with respect to t, you get 2. So you must multiply the answer by 2. So you have 2 e to the power of 2t minus 3. That's dx dt, which means what we're looking for, which is dt dx, would be 1 over that, the reciprocal. 2e to the power of 2t minus 3. So when we put them together, we can say dy dx is going to be dy dt, which is dy dt, sorry. Why did I write dy dx? That's dy dt. So dy dx will be dy dt, which is 4 over t, multiplied by 1 over 2e to the power of 2t minus 3. So that's going to give us, well, the 4 cancels here with the 2, so you have 2 on top, 2 over, and this is going to be t times e to the power of 2t minus 3. So that is what dy dx is in terms of t. Right, so we know, we want to find what the gradient is, we want to find what dy dx is when t is equal to a. Okay, or we know that dy dx when t equals a is equal to 2. They told us that the gradient of the curve is 2 when t equals a. So dy dx when t equals a is equal to 2. So how do I translate that into what we have here? Well, we know dy dx is 2 over, now when t equals a, that's going to be a times e to the power of 2a minus 3, and we know that is equal to 2. If you rearrange this, you can divide both sides by 2, so you're left with 1 on top. So we're left here with 1 equals a times e to the power of 2a minus 3. Now we want to express the answer in this particular form here. And you can see that in this form we have a ln here. As it is now, we don't have a ln here, right? So what we can do is we can take the ln of both sides. Say the ln of this side gives you ln of 1, and the ln of that side, you have ln of a times e to the power of 2a minus 3. Okay, so now we know that the ln of 1 is equal to 0, so I'll continue. Ln of 1 is equal to 0, and I can split this up using the laws of logarithms. That will be the ln of a, and then you're going to have plus, I'll do this step by step so it's clearer to you, ln of e to the power of 2a minus 3. Okay, so I've just used the law of logarithms. The ln of ab is equal to the ln of a plus the ln of b. Now I can use the power law here. So I know that this is going to give you 2a minus 3. It's like basically the ln and the e functions are inverses, so they cancel each other out. Or you can think of it as we're going to use the power law. So you have 2a minus 3 times the ln of e, and we know the ln of e is equal to 1. Okay, because log to the base e of e is equal to 1. That becomes 1. So now we're left with this. Now if you look at the answer that we have to have here, it looks like that this a has been made the subject. This a has been made the subject. So if I rearrange for this a in this formula, so I'm left with here ln a plus 2a minus 3. If I make this a the subject, I can add 3 to both sides and take away ln a from both sides, and then I can say a is equal to a half times 3 minus the ln of a, and that's exactly a half times 3 minus the ln of a, exactly what we had to show. And there's the answer to part A of this question. Now part B of this question is basically a different topic than this. This is to do with parametric equations. Part B is to do with iteration and numerical solutions or numerical methods. And so what I'm going to do, as I want to keep the topics according to the playlist to do with the topics, as well as the playlist to do with the paper. I'm going to stop this video here, and part B will be in the playlist for the specimen paper. Okay, and I'll save this video also in that playlist, as well as a playlist for parametric equations, but part B will also be in the playlist for numerical solutions. I want to keep topics kind of separate, so that I can save them in the relevant playlists easily. So I'll stop this question now, and if you want to find other questions from this paper, including part B, you can click on the link over here. The link down here will give you questions to do with parametric equations from P3 of Cambridge. Okay, and as I've just started making these Cambridge videos, you can go to my Edexcel parametric equations from that's in P4 of Edexcel. You can find lots of different questions on that which are relevant to this. They're basically the same kind of topic, same difficulty level and everything. You can find those questions in the playlist over here, and you can subscribe to my channel by clicking on this link. Thank you for watching, and see you soon.